So, yep, I'm here to talk about building native Kubernetes integrations with operators, but really, turn it on. It's really operators, 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 operators. So sorry if you're playing the operator drinking game, because my name's Nick Schuch. I come from Bundaberg, so 2 flights north of Australia. My career, I started off as a Drupal developer, and then Docker happened, and then I fell in love with Docker, and then I contributed to the DrupalCI initiative, which was an initiative for adding Docker integration to the test suite for Drupal core. So it was actually a gate for Drupal 8 as well. So yeah, it was a really great initiative and very successful. But after that, I then moved on to Go and Kubernetes as that started to mature, and that's where I spend most of my time these days, working on those workflows on top of Kubernetes for deploying applications. I work for PreviousNext as a lead. We work with many government clients. We work with Drupal. There we go. And I think we're all on a journey, right? So I'm here to talk about my journey and how it relates to operators. But yeah, we're still all on this journey, as we can see through all the talks. And I guess this journey is going to kick off with Kubernetes. So when Kubernetes was released, it was this big change. So we were running Docker for a lot of our local and non-prod workflows, and then Kubernetes came out, and it's kind of like this API on top of everything that we needed. And with that, I think I did what a lot of other people probably did, and then said, hey, we can build a PaaS. I'm pretty sure I can build a workflow on top of this thing. So in a bit of a weekend hack, Christmas hack project, I built this little CLI that then talked to Kubernetes, which then talked to a whole bunch of different APIs. And this was around Kubernetes 1.1. We kicked things off, and then we kind of followed the releases from there. So I still remember having to migrate our stacks from replication controller objects to deployments, like the early deployment stuff. So that was really fun. But as you can see here, we ended up with a very simple app after that proof of concept. We ended up with a CLI API combo, which then sort of fanned out into a whole bunch of Kubernetes objects to orchestrate a Drupal deployment. Cool. But as a part of this, there were a lot of gaps. If we think about that slide again, the whole thing was push-based. So when we did a deploy, that's when all those objects got updated. And I'm sure if anybody was working in this kind of fashion, I've heard a lot of cases where this was a thing, it was always push and then the objects would get updated then. It wouldn't be this loop cycle of keeping things in sync. So if you rolled out changes to your API server, then you would find out later on after people deployed, on how things went. So the second gap was external services. So going back to that first slide, there's no database here. There's, we're on AWS, there's no CloudFront. There's no mounted storage. So for that, we had to go and provision it ourselves and then set it in the config map and kind of wire it up as the last piece. Essentially, ops was a part of the platform. We were just baked into the platform. People would deploy for the first time, and we would go off and provision services and set stuff in config maps to kind of finish it off, give it that last push. But it was okay from there. Cool. And then operators happened. And this article's from 2018. Operators happened well before then. But this is the article that kind of captured me. I'd heard about operators for a little while. They were sort of rumbling. I believe this article references another one from 2016. But as the operator framework came out, from the awesome guys at CoreOS, this kind of captured me, and I could see those two gaps and went, yes, absolutely, this is going to solve it, right? Time to PaaS it up again. Cool. So okay, cool question. How many people are running Kubernetes? All the hands. Cool. Well, you know what? I'm going to talk to you about operators, and everybody that put their hand up, you are using operators, or at least what I think of as operators. So we think about like the pod to kubelet relationship. We think about like a deployment to the controller manager component in the cluster. Ingress, you know, we define an ingress, but then we have to install some custom code to then reconcile that the way that we want it to be, whether that's through Contour or HAProxy, or we rolled our own right in the beginning, which was Nginx, now HAProxy, then Contour. But then taking that to the next logical step, we now want custom APIs with custom controllers. So this is where CRDs come in. So we'll talk about that first piece. We'll talk about the custom API piece. So Kubernetes has this resource called the CustomResourceDefinition, and it's broken up into 3 pieces. The first one is metadata. So when we're defining these objects through CRDs, we have metadata for our objects. So this is everything from name to namespace, labels, annotations, all the discovery, all that higher level, consistent naming and discovery scheme that Kubernetes has. The second one is the spec. That's us saying, this is what I want. Like, make it so, please. Make it happen, you know. And then finally, status. And this is that custom piece of code coming back. This is the operator, the code coming back and saying, this is what I've done. You know, you told me to do this. This is where I'm at. Cool. And when defining these, we can define a test object through the CustomResourceDefinition API. We can give it a name. We can give it plurals. This has gone through multiple iterations. It used to be called third-party resources, now CRDs, and it's in beta. And then this gives us the ability to then declare we've just declared our own types. Now we can go ahead and then call that API and say, so we declared the example, now we can create examples. And this is super, super powerful because this is, you know, this paradigm just allows us to extend Kubernetes in new ways. Next, we have the controller piece. You know, we've got that API, but then we have the controller, and the best way to talk about this is just like a little bit of code. It's just a function getting called over and over and over and over again. But yeah, and an API is a loop which does one thing and does it well. And I want to touch on this because it's kind of like the Unix philosophy embodied in Kubernetes, or I like to think of it that way if it's done right. So like you have like a very simple operator. And we love them because they've already been executed well. Like we love Kubernetes because we have all these objects. We're using this system already. We're already using deployments and ingresses and pods. So continuing on with our journey, operators captured us, and then it was time for a rebrand. So yeah, you know, like all good projects, we just trimmed off some letters. So, and we have some operators in this repository. It seemed like the right place to put it. But this was kind of like a V2. It was a way for us to say, okay, taking this model now, like let's actually implement the stuff in operators and keep this sync going. And this is a really scary diagram. It's not meant to be readable. It's just kind of showing like all these pieces, like all these APIs talking to each other, and then the ones in core. And it really does kind of speak to that, like do one thing, do it well, because we have things like ingress is then doing stuff like creating a CloudFront object and a certificate manager object and a WAF, and then those go off and do those things and come back. And to do all this, we use Kubebuilder. So at the time, we had a lot of options. There's a lot of frameworks out there. There was Operator SDK from that doc. I had a play with it. I liked it, but Kubebuilder really captured me because it's got amazing documentation. The current documentation takes you through creating a cron job, which is intense. The example they use because it essentially touches every piece of the framework. So you're implementing that control cron job object that then creates jobs, creates pods. So yeah, Kubebuilder captured me because of the documentation. And so we're going to use that to kind of step through how to build a controller. But as it turns out, anybody that follows TGIK, which is the Heptio in our VMware show run by Joe Bader and a bunch of other people, but Joe did this one. He just recently did like a 2.5-hour live stream with a bunch of people building a controller with Kubebuilder. He built a Minecraft controller. So, so the goal of this talk is more to talk about the high level and to get you started and the things that you need to think about. And then then you can go off and read the docs and go through that scenario and go to this incredibly awesome resource and maybe play some Minecraft on the way too. So cool. So so to take you through this journey, we're going to do what all good demos do, and we're going to build a SaaS. Cool, but it's not what you think. It's going to be submarines as a service or subs as a service. So we're in the sandwich business, and and if this startup works out, well then we're going to open source the platform and we're going to do PaaS. But that's not what you think. It's actually Panini as a service. So yeah. Sorry, I've had way too much fun with unsplash.com and just went nuts and researched sandwiches. So cool. So let's get started. My bad puns and jokes. So we're going to bootstrap a project. So to do that, we're going to assume that Kubebuilder is already installed, and in 3 commands we have set up our project. We've created an API. And then we've run through the whole process of testing it, installing it, and running it on the cluster. And to me, this was incredibly powerful. It really showed this narrative on how to build and run and deploy operators. So as you can see, our startup kind of hijacked the container camp domain. So everything that we build under here is actually container camps. And then we're creating a sandwich group because we're probably going to have more sandwiches one day. Remember that Panini? And then we give it a version. So we're just going to go straight to V1, but because, might as well. But that version can be everything that we've worked with Kubernetes objects like V1, Beta 1, Alpha 1. We can go through that whole process. And then finally, yeah, test, install, run. Which will run the whole thing on the cluster, which is great. So we bootstrapped. Now it's time to do a bit of architecting. So we have to architect our API. We've got this sub business, but what do we how are we going to provision subs? So first, my goal when I'm architecting APIs is I want to provide intent without overwhelming whoever's using the API. So, we already have things like pods, which are huge objects, but the whole idea with CRD is to put that abstraction on top, these higher level objects. Like, we're not trying to, build these really, really verbose APIs for the most part. When doing this work, we want to provide an API for somebody to consume that's easy to use. Cool. So the first thing we can do is kind of mock this thing out. We can mock out our API. So Kubebuilder generates a sample, a very simple sample for you to start modifying, to play it out. So you can assume the role of the user that's going to be provisioning this object. And then from there, we'll first kick off with the spec. So this is the spec that I ended up going with and I'm going to use for all my requests in this kind of step through. And yeah, so like every good sub, maybe it's a meatball, maybe it's toasted, maybe it's got some salads. We can extend this API as we go, so we can add more salads as we want. But this is just like a very good, it's a very clear definition of what we want, what our intent is for the platform. Cool. Next is status. So we need to think about what we're going to return to the end user. And for this, kept it very simple. We want to know the maker. Like we want to know who made it for auditing reasons. We also want to know like the user can maybe go talk to that person. And start and completion time, so maybe we can get some KPIs and have a talking to them later on. But after we've architected that sample, then we can go dive into a bit of code. So Kubebuilder is written in Go, which I'm very proficient in. I enjoy a bit of Go. But here you can see that we've embodied that API as structs in Go. And if you're looking at this and feeling really overwhelmed, well, once you've done this, like you get the rest for free. Like you get this object and all the files to provision it, and the test suites and everything starts to come through. So, but yeah, this will provision all the YAML files that will then get run on the cluster to install your API and do validation. So it'll check if it's a Boolean or a string. It's just really, really cool to generate this. And yeah, then once you've done the API, test, install, run, and run that thing to make sure that there was no errors. Now, like all good APIs, we want to write documentation. Let's not write the code yet. Let's think about, like what we're going to, give our end users. We're still in that mind space, so we're going to write some documentation. And in my journey, it was actually pretty tough to find something to do docs. Like I wanted something that was just as simple as generating all the stubs and generating all the YAMLs from the structs that I just created. And I found this. I found this through Twitter. And I'm shocked that it's only 58 stars. It's such a great tool. I really love it. Please smash that star button. But what this will do is it'll take those API objects and the comments that we had before, and then it'll convert it into documentation for you. So right in line, you can specify your intent and what that field was intended for, and then it'll create docs for you. And this project's being used in quite a few well-known projects, like Knative. In fact, the reason why I found it was because I saw Knative. I was like, that's pretty awesome docs. Then I saw Kubeflow. I'm like, okay, there's a pattern here. Then Agones, I think. And like, okay, and yeah, like seeing the output from this doc is super cool. Like I don't want to write stuff twice. And I don't want to tell contributors to a project to have to also write the docs, like if they can do it in line with their code. So, oh sweet, I had a slide to kind of demonstrate that as well. Anyway, cool, so we've done all the API pieces. So we've gone through, we've, architected our API, done the documentation, we've been good citizens. Now we can get into the fun bit. We can do the reconcile loop, we can do that controller piece. And you know what, spoiler alert, it's just like writing a HTTP handler. It's kind of the same thing, really, when you think about it. But instead of with HTTP handlers, you have requests come in, and those requests, when somebody hits your API, you have to do it all. Generally, like, you'll go through and you'll do all the things and then return a 200 or a 500. But when it comes to these event loops, or these controller loops, it's powered by events on the cluster. So it could be something happened, like a deployment object changed, or a config map, somebody added something to a config map, or when you think about cron jobs and jobs, the relationship between those two, when a job finishes, it updates the cron job API. It's all event-based, but conceptually it's very similar. But then there's also this other powerful piece, which is like, come back later. So it's like, you basically want to loop through and then get out as quickly as you can. Like you just want to loop, and then if you're provisioning, say like a database server or something like that, if you're using AWS's RDS service, you want to loop through, create it, check the status maybe, and then exit. Like you don't want to wait for that RDS to finish. You want to inform your users and update status fields and keep that tight loop going. Because you don't want like a 20-minute provision time. So, cool. So for writing the controller, this is what version 2 of Kubebuilder gives you. minus the comments. They don't deal in submarines. But this is kind of how we're gonna build it. So yeah, first we're gonna load our object, then we're gonna run through a bunch of steps, and then we're gonna update the status. And what I'm trying to demonstrate here for everybody is that, like, think about it as like an ordered step. Like, this is how I like to write operators, because the idea is you can go into the prepare function, the first function there, check if you need to prepare, maybe just return, and then keep going. So it's a really nice way for somebody to dive into your operator, read exactly what it's doing at a high level, and then break it up into steps. Cool. So the next thing, now that we've come through and our controller loop is provisioning subs for us, making subs for us, is events. We want to provide some, so we've got a status field, but when we think of the status field, like if we have something like this, it's like what the heck is going on? Like, it's like that dates ages ago. Like what's Nick, Santa, what's going on, man? Sorry, it's my colleague. I used my colleague's names and everything. So what's going on, man? What's happening with the sub? Like, there's no events. I don't know what you're doing. So as a part of this, as a part of your operator, you can emit events for your objects. So we know this from things like pods. When we describe a pod, we see that it's pulling the image, it's running the image, it's in a crash loop back off, all that fun stuff. So that's what the recorder, this event. So this will trigger an event which is a normal event. So we're passing in the sub, like the object that we want to relate it to, whether it's normal or warning. And then we pass sort of two params which are important. So the idea of giving it like the sandwich make section gives it identity. So you could kind of query across all the events for all the sandwich makes. And then you actually give it the output. And as we can see here, the sub's not being made because it's on fire. Somebody left it in the oven. So, but now the user knows, like, the completion time's not set because the sub's on fire. So if events are for developers or end users, well then logs are for admins. Like, we know this. So we can do something very similar and provide a very similar log, but a little bit different. So the idea would be more for auditing. So it's like, oh, that sub was on fire. Oh, cool, go back into the auditing. Oh, that maker was assigned to the sub. Okay, cool. Cool. So just like all good software, testing. Like I want everybody to think of testing. And Kubebuilder gives you the pieces to run a test suite. It gives you it stubs out all the code for you to start extending it and using a test suite. But in my opinion, this test suite is a bit slow. So essentially, every test run, it'll spin up a bunch of the Kubernetes API server and controller manager binaries, and then it'll install your CRDs, and then it'll run the tests. Which is fine, but it is very slow, and it is very slow when you add more and more and more tests to your test suite. But like all software development, we can refactor this thing into unit tests. Like, we've just got that reconcile function that's got input and output. So this is, I will be posting my slides, and this is what we've come up with just using fake client, which then runs super quick, because it's just using like the in-memory Go client for Kubernetes. So we can then create the sub, we can then chuck it through the reconciler, and then we can check and then look at what the state is afterwards, and also maybe modify the objects to kind of marry things up and check like what would happen with our reconciler if it was in X state, if like the objects were in X state, what's Y. So this is incredibly powerful, incredibly quick, and a nice dev workflow. But there's of course going to be times where you're going to want to use a real server. Another thing to think about is just mocking those events. So this has been very, very cool, because if we're emitting them events, then we can go and have like a mock event provider and then check and see if they are coming out, and like our reconcile loop just hasn't returned a nil, and it's all cool. That just provides a little bit more depth to our tests. Yeah, and if you want to run like a real Kubernetes server, we moved more towards K3s for running it because it runs in a container. I wrote a little library that's just drop-in, so you just drop it in on top of what's in Kubebuilder, and it's a little bit nicer. We ran into like a lot of memory issues with our CI and test suite because we run a lot of operators. So containing that into like a single Docker image with some mins and maxes is awesome. So now give me a star if you want, but give stars to the other docs, please. Shameless plug. Cool, deploying. So when we think about the operators that we already use, they operate in kind of like a namespace all kind of mode. So if you create an object in any namespace, it's going to react. Like the controller is going to loop and then do something with that object. But another thing to consider is, depending on how you've sliced up your platform, you can deploy that. You can install the CRD once, and then make the controller only react to objects within one namespace. Which, if it's across a team-based workflow, if you've sliced up your cluster into namespaces per team, this could be really, really handy because it allows you to roll out a fix really quickly for team A, and then let them test for a while, and then roll it out to the rest of the teams. So that's just something to think about. The other thing we also discovered was a lot of these frameworks end up in a single binary that you run that runs all the loops. And this can be a bit of an issue with security, because if you have, say, a loop which is going to provision stuff on AWS, let's just say we had 4 loops. It's like AWS, CloudFront, Certificate Manager. Another one, like the permissions that you're going to have to give that deployment is for all those services. And it essentially becomes root on your cluster by the end of it. Like once you're playing with all these objects, like it becomes root. So slicing them up into separate binaries, like just have a think about that, and giving them specific AWS creds and RBAC permissions. But to kind of manage this insanity, we have a Terraform provider because we provision our cluster on EKS. Like we provision EKS, and then we provision our control plane on top of that. So it kind of keeps it all in one spot and makes it really nice to just copy a manifest and then change a few things and get it to the right spot. So cool. Sweet. Cool. So monitoring, I just wanted to quickly cover off monitoring because we've deployed these things out now. Monitoring is pretty vital, and Kubebuilder provides you a very similar Prometheus exporter as what the Go metrics exporter does. So you can get all the Go pieces, like how much memory is consumed, but it also emits a bunch of other stuff. So this is actually like number of errors returned in the Reconcile Loop. So, and you can see I was running it, and then I fixed the issue, and now it's back to green. So, so if you already have Prometheus, this is super, super handy. And I just also want to talk about tracing, or even just like thinking about like standard like APM tools that you would for your other applications. Like at the end of the day, this, like it's still like, if you use the analogy of it's like a HTTP handler, well, the ability to break down this thing and see where all the slow parts are, because the idea is to keep these loops really quick. You want to break down that request or that resolve, reconcile, and see what's going on. So, and this is something that I'm currently exploring. So, cool. Now just down to kind of the extra mile stuff. Client set. So if you're writing an API, like think about maybe writing a client library for other people who want to consume your API. Maybe even go even further and use like and then build upon that and do like a little CLI API component. There's great examples of this out there with projects. Arc doesn't have the API piece, but it does have the CLI piece, and it interacts with those. It provides like a higher level interface for users to create backup and restore items. We did it for ours, and it turns out like Adam really loves meatball sandwiches. So, yeah. But also, if you're going that extra mile, then maybe think about like shipping a demo environment. So like repurposing like K3s, so I'll show that now. But this, like we use this for our local development with Docker Compose to spin up the cluster. So why not? And it has the ability to, you can pre-package it with manifests and images. So think about maybe like instead of telling people how to install your operator, maybe give them some docs about how to run like a pre-packaged Docker image and then take them through a tutorial. Cool. And finally, like honorable mention to book.kubebuilder.io. This thing is insane. There's so much more that you can do with that framework, but like, yeah, definitely dive into that. Dive into the scenario. If you've got like a generally, like every time I've had a question about how to use Kubebuilder, like it's in the docs. It's super, super good. Cool. But yeah, with all that, thank you, and yeah. I'll do that.